Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. In the last episode we finally managed to get an image rendered by our low-level Direct 3D12 renderer. However, as you can see, the image doesn't appear to be displayed correctly. It looks like it's facing away from us, but if you look at its thumbs, they're at a place where its pinkies should be. I'd like to be able to inspect this model from different angles so I could see better what exactly is wrong and have a better chance of fixing it. So today's video is about having the ability to move and rotate game entities using our native C++ scripting system. Fixing any graphics issues would be easier if you were able to view the scene from different angles. So before trying to fix the graphics, I think we'd benefit a lot from spending a little time and making sure that we can view our object here from different sides. We could do this in two ways. One option is of course to move the camera around the object. Because cameras are attached to game entities, and right now we can't move game entities, we are unable to move or rotate the camera. So instead of moving the camera, we can first write some code that makes it possible to set the transform component of the game entities, and by doing so enable us to move, rotate, and scale any game entity. When we have that capability, we can simply rotate our object here, which is simpler than writing code that handles camera movement. Obviously at some point we are going to implement camera movement as well, but right now just rotating the object would be enough for us to visually inspect the issues that need fixing. To that end, I'm going to start by expanding the entity class with a couple of functions that simply return the current position, rotation, orientation, and scale of the entity. Then we can add new functions in the entity script class that set each of these components. However, with multi-threading in mind, I'm not going to directly set the corresponding transform components. Instead, we are going to cache any changes that are made and apply them in the updating phase of the frame. Let me explain this a bit more here. Looking at the state of transform component as it is now, we see that any module, for example script or physics, can read data that's held by the transform component module. Reading data can happen by any module and on any thread. Obviously, if you wanted to update any of these components, you'd have to take on a challenging task of synchronizing reads and writes. Besides the fact that this would complicate the code considerably, it would also impact the performance of the engine. On top of that, you would still need to define which modules would have precedence over any other module, which results in even greater complication of the code. The way I'm going to tackle these problems is by caching any changes that a module makes to transform components during each frame. The consequence of this is that each module has its own cache, and that updating any transform component is not reflected in the transform values until the next frame. This may sound odd at first, but makes sense if we consider the fact that one frame is the smallest time interval of the game world, and entities are not going to move within the time span of one frame, during which the world is basically static. In other words, the game world advances in discrete time steps, with each step being as long as one frame. Now everyone can read from the transform component anytime, and since each module that needs to update transform components has its own cache, synchronizing writes is only needed within the module if the module uses multiple threads. In order to get all updates into transform component module, we are going to have a point in the current frame's timeline where everyone agrees that there will be no more reads from the transform module. After this barrier, each module can call an update function that will write the changes from the cache to transform module. Although it would be easy to serialize this part using a lock and mutex, we'll need to manually define some kind of priority between the modules. So for example, if an object is falling due to gravity, that means that a physics module will be updating the position of that object. However, if there is also a script that's trying to move that object because of user interactions, we need to decide which update will take effect. So this is not a matter of multi-threading, but one of engine design. With this solution in mind, we can continue and add the setter functions for transform components. These are static because we are going to use them to set the transform components of any entity, not just the ones that happen to have script components. That's why these functions take a pointer to a game entity. I'll also add some convenience functions that will set the transform components for this entity. Before implementing these functions, we are going to add an update function to transform component module that takes an array of cached transforms and overwrites the corresponding entities. So first we add the cache struct, which contains the values for rotation, orientation, position, and scale. It also has the ID of the transform to which these changes need to be applied. Because not all of these components might have been changed, we need some kind of flags to indicate which components need updating. I'll add the flags enumeration next. I don't think it requires a lot of explaining. It has one flag for each of the components, which can be logically ORed together. For example, when all flags are set, that means that all components have been changed. Using this struct, we can add an update function that takes an array of these caches and applies the changes to transform components. We can also add a function that takes an array of entity IDs and returns the flags, so we can always determine if an entity was moved, rotated, or scaled during the previous frame. In order to do this, we need to remember the flags for each entity. This can be done using a simple byte array. We also need a flag to indicate that we should reset this array when we enter the writing phase of the frame. We'll see how this works in a minute. As always, we need to make room for our data when we create a transform component for a new game entity. Returning the update flags is easy. We loop through all entity IDs and write their update flags to the provided flags buffer. Note that I chose this function to set the read flag. Setting this flag means that we have been reading from our data. We could set this flag in any function that reads the data. I chose this one because I expect it to be called less frequently, and therefore we are not unnecessarily setting this flag over and over again. In the update function, we clear all update flags the first time this function is called. We also clear the read-write flag to indicate that we have entered the writing phase of the frame. As I explained earlier, we have an agreement that from this point on there will be no reading from the transform data, so we can rest assured that this flag is not set until the next frame. Then for each cache, we check which flag is set and update the corresponding component. I'm going to write a separate function for each of these. For the rotation, we update the entry in the rotations array. We also need to recalculate the orientation, obviously. Clear the has transform flag so that the transform matrices will also be recalculated when someone asks for them. And we set the update flag for rotation. I'll skip the orientation for now because when we set the orientation, we also need to calculate the rotation, and I haven't figured out how to do that yet. Not that it's complicated, but I just haven't got around to writing the code. Updating position and scale is done in a similar fashion. Passing the right parameters in the update function will finish the code for updating transforms. In the script component, we can add an array for caching the updates that happen in the game code scripts. We also add an unordered map for looking up the entities when they are updated multiple times. Just quickly, I'd like to get rid of this warning that we get because of an unused local variable. We are not using entity type yet, so let's just skip it for now. Back in the script component, I'm going to add a function that will look up the cache for an entity. So this function checks if there is already an entry in the cache for this entity. This is done by trying to add a new key value pair using the transform ID of the entity as the key. If an entry didn't already exist with this key, try emplace will add it and return a pair with the second item set to true. This is false when the entry already existed, and in that case we simply return the value, which is the index of the cache. In the update function, after all scripts have been executed, we can send the cached updates to the transform component module and reset our cache array and map for the next frame. Next, we are going to implement these functions, which use the transform cache to record any changes made by scripts. For each of these functions, we look up the pointer to the transform cache for the corresponding entity, set the component's data and the flag for the component that's updated. I see I forgot to use the correct type for these parameters. Now we are basically done. However, I'd like to implement another way of looking up the updated entities in the cache. Using an unordered map is in theory faster for a large number of lookups, but I don't expect thousands of entities to be updated during each frame. In addition, unlike the vector class, the unordered map does memory allocation and deallocation every time we add and remove entries, which could hit the performance as well. That's why I'm going to make another implementation of our lookup function, which does a simple linear search in the cache array instead, and we can toggle between the two implementations using a compile time constant. As I mentioned, we simply loop through all cache entries and simply return the cache with the same ID. If we didn't find an entry, we add a new one and return its address. Obviously, when we don't use the unordered map, we don't have to clear it either. This is all we have to do to update entity transforms using gamecode scripts. The project built successfully for both lookup strategies and it's ready for testing. Let's head over to Test Renderer and create a game script that we can attach to our object here. We already automated this process using the level editor. If you'd like to know more details about the native scripting system in Primal Engine, feel free to watch these videos. This is a nice showcase for creating scripts without having to use the level editor. What we are doing here, in fact, is that we are creating an actual game using Primal Game Engine. So to add this script, we need to create a class that inherits from entity scripts and implements the update member function. We are going to rotate the entity in the update function. I need a constant for 2π, and I think we already have 2π defined in our math types, so we can use that one instead. We do need an angle variable that we can advance after each update to make the character turn around. First, we construct a rotation quaternion from the Euler angles. I explained the mathematics of this conversion in this video. We use this quaternion to set the rotation for the game entity. The final step in using the script is to register it with the engine. We are going to stop here for today. In the next video, we are going to get this part up and running, and we'll also fix the graphics. Thank you so much for joining me today, and I hope to see you all next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!